Okay, so we're learning programming in Python, and I want to introduce to y'all the big three components of programming in any language. And my goal is for thinking about these three components of programs in the abstract to allow you to break down problems more directly and build up solutions in a more durable and rapid way. So the big three components of programming are the three ingredients of algorithms. And we'll talk about what an algorithm is too. The big three ingredients are sequence, selection, and iteration. And so let's talk about what an algorithm is. An algorithm is a formalized sequence of steps to solve a problem. We can think of a cookie recipe as an algorithm. As an example, if you follow that cookie recipe to the letter, you're following an algorithm. If you've made 1,000 batches of cookies and you wing it, that's not really an algorithm, it's intuition, right? So a cookie recipe is an algorithm following each step to the letter. We can also say calculating the average of a list of numbers is also an algorithm. There's a sequence of steps. A comes before B, comes before C, and then we have a solution, right? We can have more complicated things, right? TurboTax runs algorithms or sequences of steps to determine your tax refund or liability, right? So algorithm is a magic word when it comes to computing and computation and thinking computationally. And I'm going to share there are three parts to algorithms. And when I say three parts, an algorithm can have one of these parts, two of these parts, all three of these parts, 100 parts that are all based out of these three. Right? So let's talk about what these are. Sequence is the most fundamental, and I'll share, these are the three most fundamental pieces of programming other than thinking, other than just sitting your butt down and thinking about the problem. These are the components we need to think with when we produce a solution for that problem, right? And these three components, they're super big, but they're also the most often misunderstood components in programming, right? So let's talk about each piece here. So sequence is the following. Sequence is order of operations. This could be PEMDAS if you're doing math, parentheses, exponents, multiplication, division, addition, subtraction. And there's also, when we talk about PEMDAS or order of operations with a programming language, there's order of logical operations. So there is an order of operations for and, not, or, but rather than memorizing that order of operations, use parentheses to make your order of logical operations concrete. So either parentheses or lines of code. And another aspect to sequence is code runs from top to bottom, unless told otherwise. Right, line 1 runs before line 2, runs before line 3, unless you've got a notebook and you purposefully run things out of order just to feel crazy, just to drive yourself bananas. So sequence is all about the sequence of the steps in our recipe, in our algorithm. So code runs from top to bottom unless told otherwise. You've probably seen a couple of different function calls. So functions run from inside out. That's 1, 2, 3, 4, 1, 3, 4. When I say functions run from inside out, does that mean anything to y'all right now? Or what does that cause you to think about right now? Nesting functions. Like incrementing the increment of 1 should give us 2, right? So our functions run from the inside out. This is all part of sequence here. And we can take this one more step. We can say methods run from left to right. So the difference between a method and a function is that methods are functions that live on things. Functions live on their own. They have their own names, like length or sum. Methods are attached to other objects in Python or any other programming language. Methods are attached to objects. So I'll put this in the comments here. Methods are functions that live on objects. And when I say objects, I'm talking big tent here. I mean, arrays are lists are objects, strings are objects, right? And just the simplest example of line 1 runs code, then Python runs line number 2, etc. That's sequence. And so something I realize that y'all are hit with parentheses, with code running from top to bottom, but something that might not be immediately apparent to everybody since we just learned functions is that functions run from the inside out, they evaluate from the inside out, methods run from left to right. That's important to know. Yes, Lincoln.
Example of, let's say, methods running from left to right.
Yeah, absolutely. So the question from Lincoln, in case y'all didn't hear it at home, was example of methods running from left to right. Here's what I mean. Say if we have some, let's pick on the Beatles. So John, Paul, George, and Ringo. If I were to do Beatles, let's see. Do I want to do this with a list? Maybe I want to do this with a string. And insert. I think it'll help understanding if I do this with a string. So we're just going to make this a string. So I have a string, just a nice plain old string. And when I say methods run from left to right, if I were to say, lowercase everything, the lower runs on the Beatles string. And then if I were to chain on another method, I realize I'm introducing or reaffirming chaining methods. So I'm going to lowercase everything. And what if I were to do a swap case on everything? So swap case finds whatever case a string currently is and then changes its case. So reading from left to right, we take the string, we lowercase the string, then we swap the case on the string. Yeah. And then maybe we could do another, we can just keep chaining if things return the right stuff, right? We could do dot replace on Ringo, capital Ringo, with yield-pert. So see how moving from left to right, we lowercase everything. Then we swap the case to make everything uppercase. Then we replace uppercase Ringo with yield-pert. And that's the left to right. Yeah. I want to open up for questions about this first component. And when I say open up for questions, I mean like ask the burning question. Because if you think you're going to study your way to understanding these three things at 6:30 p.m. tonight or after dinner, my advice to you is let's talk turkey now. Let's talk shop now. It's not to say that you can't understand it, but the sequence thing is important because if you're mixed up about order of operations, you're not going to have a good time with conditionals or loops or anything at all, right? Nothing too crazy? Okay. It's kind of a big deal. Sequence sounds simple. It's easy to wrap your head around. But sometimes our sequence, we can tell our sequence what to do. We can tell it to run differently than just top to bottom, right? Inside out or left to right. So let's talk about selection. Selection is deciding what to do based on.
Ryan, sorry, I have a question.
Oh, yes, please, go ahead.
So I was trying to read through it and see what comes to my mind. You said that you wrote that order of logical operations, use parentheses or line of code to make your order of logical operations concrete.
Yep.
So in the case of the nested functions, if you're using a function combined with a method, which one is gonna run first? Is it still gonna use the nesting aspect and then inside the method work it from left to right?
Yeah, so it's going to depend. So Arsene's question was about how do we mix and match functions and methods? And the answer is we could totally mix and match them. So let's talk about that. So in the example that I shared earlier, with the methods left to right, what if we were to take a function like the length function and wrap the length function around everything? This is a thought experiment for the class. What is length going to operate on?
I would think that it's going to first look at everything on the inside, so it's actually going to do your methods first.
Yes. So in case you didn't hear, I think I saw the answer from a couple of folks at the same time. The length function is going to operate on the expression that's inside of it. So if functions operate from the inside out, well, what's the inside? It's the expression that is that chain of methods. Consider the following. If we took that expression from earlier and assigned it to X and then answered length of X, all this stuff is substitution. When we evaluate 2 + 2, we get back the answer 4. So anywhere where we see 2 + 2, we could use the number 4. Just like anywhere where we send X in will be completely identical in its execution to if we pasted in what X used to be. What's that?
It seems more like I understand more once I see the example.
Yeah.
Makes sense.
Principle of substitution is a pretty big deal with sequence as well, because we define variables in the sequence of our application. You look like you have a question. I'd love to hear it. Jen's gonna beat you to it.
Well, I was gonna share that I had a really good example
Yeah,
of how the order of method matters.
sure.
For instance, in our function exercises, I had tried, and I don't go into more detail, but in just like the normalized name, I decided to stack methods. Found that I was putting the method of lower, I was putting the method of strip to take away the white.
Yeah,
And then I was also using the method of replace, so I can replace any blanks in the store. And so for instance, in that case, I had the return name dot place and then a name dot strip. And so instead of it returning the name, which was kind of funny, it instead underlined everything. Like it ended up underlining everything rather than actually like closing it. And so I was like,
Yeah.
oh, great, I messed up, but then I realized if I just swap the two, it was fine. So
yeah.
I know it doesn't quite make sense probably without a visual, but
Can we jam on this a little bit?
Yeah.
This is going to be less about methods, I think, and more just about order of lines of code. So let me be even more explicit here. The order of our lines of code, period. Yeah, very explicit. So let's talk about that normalize name function. Lowercase, all the things, convert spaces to underscores, strip any trailing or appended white space, and then filter out only valid Python identifiers. So what I'm going to do first is build kind of an example string, and I'll have a whole bunch of trailing spaces, some spaces in the middle, and I'll say Python at CodeUp rocks. Rocks and exclamation point. So looking at this string, conceivably, if we follow our appropriate answers, the correct version of the string should be Python CodeUp rocks. If we lowercase everything, remove all the special characters, remove the prepended spaces at the beginning and the end. Are we in agreement on the input string versus the correct version at this point? Okay, cool. So let's talk about this. Now, when we talk about sequence, if we were to say, take that string and say, hey, string, replace all of the space characters with underscore character. If we happen to do this first, what do we get? We get too many underscores. We want the underscores in the middle of that string, but not the prepended. So sometimes we're often going to be, we're going to swing at the problem and we're going to almost get it. It's not a loss. It's kind of a foul ball, right? All we got to do here is think one more step. It's tiny little steps. What needs to happen so that I don't convert all of those spaces to underscores too soon? Any takers?
You gotta strip it.
You got to strip it, right? So we do string.strip, right? Now, for the avoidance of doubt, I'm purposefully creating a problem. I added string.strip. I'm going to run my cell again to prove that I just added string.strip. What's going on, Jackie?
You gotta reset the string to string dots.
Yes. So Ryan Miller called it, we have to reassign strings. So there's something worth knowing. String methods, might as well put this in our comments here. Now we know string methods return a copy. They don't alter the original. So to save the result of transforming a string in some way, either a substring or an uppercase version of a string or a replacement on that string, we need to reassign the variable or use another variable. Usually in this case, I'm going to keep reassigning string over and over. So yeah, V is totally correct. We need to strip that string. Now here's what happens. This strip runs. If we were to take a look at the Python code that's running underneath the hood, that strip happens, but it's just like typing the number 5 somewhere or the number 4 somewhere. We don't give it a place in memory, a bucket in memory to hang on to that strip string, right? If we did string.strip, that strip happens. Or let me back up. If we strip that string, the strip happens, but it doesn't persist in memory. And this persistence in memory is a big deal because it is related to sequence and our understanding of how things run and in what order. So yes, we do want to strip our string, but we have to hang on to the transformed version. So when does order matter? Order matters a lot of the time. Sometimes it doesn't matter, right? 2 plus 3, 3 plus 2. Order doesn't matter if we have a commutative property, right? So sometimes you're going to hit those really close shots where you realize you've got to go back to the drawing board. That's an opportunity to slow down. I encourage you to avoid beating yourself up because you're a human, you're just learning this stuff for the first time. But also, you know, if you run into an error, a new error, it gives you some new information on what to do and where to go.
There's something in the chat.
Oh yeah, thank you. Yeah, Mindy's asking, can we put strip and replace on the same line? Yes. Can we see where that goes, how that goes with this example? Yes. So in this space, I want to strip the string first, and then I want to replace any remaining spaces with underscore. So we could do this in one long chain if you want. This is only a matter of style, but you got to have your head on straight if you're chaining a whole bunch of methods together, and order matters with the chaining. What if we said, give me 1 second, David. What if we did the replace before the strip? Any takers on what we would get if we ran the replace before the strip? We'd get too many underscores. Yep, you got it. So orders matters when it matters. And then you would still have to reassign. Absolutely, Mindy, you do have to reassign unless you're in a function where you're returning, because returning is handing the value back to the rest of the program. In this space, in this example, I'm going to give you an example of when order does not matter. Oh, that's right. I'm sorry, David. Go ahead.
Scroll back up. I was trying to see. So if you put the lower before swap case, would that change the entire?
Right here?
Yes.
A lower is before swap case.
I mean, if you switch those around,
Oh yeah.
you basically get everything.
We'd swap the case and then lowercase everything. Yeah, let's check it out. The answer is yes, that will change things. I need a dot there. Okay, look at that, 29 versus 25. We have a difference here, right? Let's see what that difference is. The replace never happens on a lowercase Ringo. In this case, because the order mattered on the swap case versus lower. Yeah. Yeah, did that answer your question, David? Awesome, thank you. And Jen, thank you for reminding me. Question from Bert.
So I typed that in exactly the way you did, and it doesn't strip for me for some reason. That should be the one.
If it's exactly, then, I mean, these are deterministic systems, right?
Yeah.
So there's got to be something that's not exactly the same. You want to send me your code or plug in?
I just showed you.
Yeah, come on down. Come on down, Bert.
I'll have a different computer on Wednesday, so maybe it's the computer, but.
Yeah, this is great. This is a perfect example. Your strip right here never stored the output of strip to memory. You did the operation, but you didn't store to memory. So I'll show you what I mean.
Okay, let me sit down so I can type this.
Yeah, this is perfect. So line 1 is this one-liner is equivalent to the two-liner below. Now that two-liner below, the string is string.strip. String is string.replace. Yeah, I'm glad you brought that to my attention, Bert. Yeah, essentially, you were stripping, but you weren't storing the result of that strip to memory in this one-liner, or if you did the method chaining, it's evaluating that entire expression from left to right and then assigning it to the variable on the left.
That makes a lot more sense.
Cool. Yeah, thank you for saying something. We have a richer discussion when y'all let me know what's troubling you or what's concerning, right?
Yeah, otherwise, I'm like an hour behind. It's like,
I'm glad you said something, yeah. So this order matters, and I'll share in this example where order does not matter. If I were to lowercase everything at the end or the beginning, let me put this in its own little thing here. If I lower at the end or if I lower at the beginning, in this one case, because lower and strip and replace they're not dependent on each other, we get exactly the same result in cell number 29 as we do in 30.
And you just have to have it in mind.
In the end, you got to have the end in mind. Yeah, and you got to have your head on straight, right? You got to slow down and think about things before just slinging code. Just because code will be the answer doesn't mean that any random code that looks like code is the answer, right? Yeah. So the lowercasing doesn't matter on order here. And I'm going to bring this specific example around a little bit. I'm realizing I want to remove any special characters like the @ symbol and the exclamation point. And I can't really chain that unless I know beforehand what those characters are. I could do a replace on exclamation points, but what if somebody gives me a pound sign here? And in this example, there's not a one-step solution to replacing all of or at least with what the tools that we have right now, there's not a one-step solution to replacing any and all special characters, right? So you might see, I think in Adam's work, you saw a for loop. We could do, what I'm going to do in mine is do basically the same thing, letter for letter in string, if the letter is a valid identifier. And I broke it. Letter for letter and string. I've got all the right stuff there. I'm getting a little ahead of myself here because list comprehensions. are iteration. They're an iterative tool. So I'm gonna put Humpty Dumpty back together again over here. We'll talk about list comprehensions in just a moment. And when I compare my new output to the correct output, Python code up underscore rocks. All right. Cool. We talked about a couple of things. We talked about order of execution, the order of lines of our code matter. The order of mathematical operations matters. The order of calling our functions or our methods or even blending them together, that also matters unless it doesn't, like in that case with the lowercase, right? But sometimes even the tiny things matter. So this is really why a lot of our coaching and guidance is to slow down and to plan things out on paper or diagrams or little block and stick diagrams, because all of the fancy code keywords in the world aren't going to magically solve the problem. Thinking solves the problem. Right? Is this helpful? Is this useful for y'all? Cool, cool. Yeah, Jason, what's on your mind?
Yeah, comments.
If we had comments, we can't put comments in the middle of a line of code, but we can put comments at the end of a line of code. Yeah, original string. So if I put a comment character like right before the equal sign, see how it comments out the rest of that line of code? And then we'd have sometimes a syntax error. Yeah. Can I put each method on its own line? You bet your boots I can. So we don't have to chain everything if you don't want to. Method chaining, kind of like ketchup. You use it if you like it. Right? You need to understand method chaining runs from left to right. But if you like to do things one step at a time, nice and methodically, we can do things one step at a time. And that's probably a great idea until you've done 1,000 functions, right? So we can say Beatles is Beatles lower. And then we can say Beatles is Beatles dot swap case. Then we can say Beatles is Beatles. We'll replace poor uppercase Ringo. I might be mistyping Neil Peart's last name. There might be an A in there. See how we get the same result chaining as we do methodical one step at a time. So lowercase, all the string. And we swap case the string, meaning all lower becomes capital. And the reason I'm lowercasing and then uppercasing here is to show that order matters and to demonstrate that left to right execution of methods, and then replace Ringo with. Did that speak to your question, Jason? Your comment? Oh, if you can method chain on multiple lines, is that your question? Yeah. Yeah, we can totally do that. So in case you didn't hear Jason's question, can we method chain from left to right, but top to bottom. That's your question, yeah? Yeah, here's the answer. You take your method chaining. And we can do a continuation character, which is a backslash after each line. We could use a backslash, between each line, or you could do wrap everything in parentheses to avoid the continuation character. I'll show you what that looks like. We get rid of the continuation characters. Parentheses.
Backslash just mean next line.
It means don't terminate. So backslash means is the escape character. It means don't do what you normally do. So an example of a backslash character would be the backslash n, which is a new line, and then we can print hello. See how there's a space and then hello. So the backslash is saying, hey, letter n, instead of being a letter n, do your other job. Now, the other job of the letter n with a backslash is to be a new line character. And there's a couple of other characters like that. The default behavior inside of a method chain is to keep the chain going. So we're saying, don't do what you normally do. So in this way, we're able to break that chain up to answer Jason's question. Yeah.
So it's like,
yeah.
oh, so I was gonna say, so it's like assigning a new shortcut.
I wouldn't say a new shortcut. It's you mean the backslash here?
The backslash, yeah, to the n.
I would say this is saying keep the code coming, because the default operation for a new line is to terminate that line of code.
Okay.
I'll give a simpler example. If I say 2 plus 2, that's invalid syntax on different lines. That's because the default behavior when you see a new line character is to terminate that line of code.
Got it.
So 2 plus 2 on different lines, this is a syntax error. Because instead of, there are some other programming languages that use like a semicolon to finish a line of code, like a Java, right? Well, this isn't Java. Python is Python. Python uses a new line character to terminate a line of code. So we could use the continuation character. This is kind of an obscene example. That's a lot of characters for 2 plus 2. Or we could do 2 plus 2 in parentheses. Isn't this crazy? We're getting a lot of depth in this conversation, and all we're doing is talking about sequence. Right? This stuff blows my mind. I love it. Yeah, Stephen. Like this?
In a function. I think.
Well, I've purposefully messed up our line indentations here to demonstrate that the continuation characters keep the party going. Keep the line of code going, even if it's all messed up. Now, if you write code like that, I'm going to get on your case, right? Especially for 2 plus 2. And that's because the indentation in Python is important. Other curly brace languages like Java or C use curly braces to tell you what the body of a control structure like an if or a while loop is. Python uses indentation. Yeah. Great stuff.
Thank you.
Yeah. So some perspective Variables are abstractions for values. Values like the number 2 or the name Bob. And we can, our variables will always point to something or give us a name error. It's about that simple, right? Our type errors, like our type errors are errors in sequence and what we're doing in the sequence. So we can't take 2 and add the string 2.5. That's nonsense. That's a type error. Python doesn't know what to do with that. Python's like, do you want me to treat this as a string or as both numbers? So when we get a type error, it means we need to slow down and think about what's the sequence of steps that we're saying and what is incorrect about what we're telling the computer to do, because it'll do what we tell it to, no matter what, right? Computers run the code they're told to do, not the code you want them to do. And that's important. That's an important takeaway. Computers run the code they're told to run, not the code you want to run or expect. I imagine a lot of y'all are running into this one, and we all do, everybody in the industry. Our mental image is different than what we typed, right? And that happens from time to time. You want to talk about selection? We got into a lot of depth on sequence. Selection is quite simply selecting what runs. That's the simplest way of putting it. Things that are selection are conditionals, like if conditions, if else conditions, if else, elif. You can write 1,000 else ifs here. Else. These are all ways of selecting. With selection, we're controlling what code runs and what code doesn't run. It's that simple. And so an if else is a fork in the road. There's no other option. Left or right, no other option. And if on its own is a side quest, is a nice little side quest. If it's raining today, I'm going to bring an umbrella. That doesn't change anything about the rest of my day. But if it's raining today, I'll bring an umbrella. Else, I'm going to wear flip-flops. That's an if else. And then if we have an if, elif, elephant is as many forks in the road as we need for the problem. And I'll give you an example of selection in the real world without any code. Let's talk about this. We can say if, and we're going to build this out in a little code example here. If stoplight color is green, you proceed safely as a function, right? If stoplight color is red, say come to a full and complete stop. Now, these are obviously not defined functions, but y'all know how that works. Okay. Now, if I threw an else on here, this would capture our yellow lights, but we have some other conditions on a yellow light, don't we? If you can make it through safely, then proceed. Else, if you can't make it through the yellow light safely, come to a full and complete stop. And in this example, I don't have another else that catches all, but if there's no stoplight color at all, if it's not red, yellow, or green, you can do a joyride. What'd you learn at Code Up today? To do a joyride. So what I'm selecting here is a function of real world laws, and we're modeling a real process. Sometimes the process that we're modeling is a mathematical process, right? Sometimes it's a logical process. I'm sorry, go ahead, David.
Just get rid of the other else and just put joyride there.
Where?
Like instead of, like right there, the first else, and just put joyride.
So if there's a yellow light and I can't make it through safely,
It's gonna automatically, if you have a red light, it's gonna say.
what I'm trying to bring up here is that there's a subtlety on yellow lights. Maybe you're a safer driver than other people. Maybe you're more reckless than other people. But if the light is yellow, we have to ask another question about the world, don't we? We have to ask, do I have enough space to stop safely? Or are you going 50 miles an hour and the light turns yellow like 10 feet before you hit the intersection? That's what that is. And so the complexity of our conditionals should not be any more or any less complex than the problem we're trying to model or solve. And I'll share the following. When do we use a conditional like an if? Here's your answer. When you need the code itself to ask and answer a question. We're asking questions about the state of the stoplight color. And then when we see that the stoplight is yellow, we ask another set of questions about the rest of the context of the situation. And so the question of if you ever feel stuck, this is important guidance. If you ever feel stuck, where you're thinking, man, I need the code to make a decision. I need the code to check something. Then you're in selection land. And the beating heart of selection, which is a way of saying control structures, right? Other than loops, right? The beating heart of selection is Boolean evaluation. Fancy way of saying evaluating if an expression results to true. Is this true or false? If you say false. So if you're ever feeling stuck and you're like, man, I just need this code to ask a question, well, build a conditional, and you've got to figure out what that condition is, right? Cool. So in this way, conditionals, which another way of saying selection tools, are an abstraction for decision making. You don't have to be there printing out the values and reading the little value. You can have your code read your code. Cool, cool, cool. If this is too remedial for y'all, let me know. I want to talk about iteration. Yes, yes, go ahead. B. Okay. Feel free to ask it. We can determine it. If it's irrelevant, then we'll talk about it later. If it's relevant, we'll talk about it now. Yeah.
When do we go on break?
That's a great question. Let's do it now. Let's do 15. I could have had another.
His else statement after basically we did it.
Yeah, yeah.
Something else.
Yeah, I think you're seeing a pattern here, David. We could do. If the stoplight color is yellow, I have a syntax error. And you can make it through safely. Proceed. See how I'm creating compound conditions?
No, bro, I was thinking like, instead of like, you have the else after the index, right? But I could add another is else statement.
Oh, yeah, yeah. If you had something to ask that code. No. The else is a catch-all. So it's like,
I'm thinking like, can you just add is else joyride and just, that's it.
you could, yeah. I'm trying to stay legal. Yeah, take a good break, folks.